Assalamu alaikum, sir. Myself Jaid Ahmed Fahim, and today I will be presenting a presentation on assignment on a digital logic circuit for metro from crowd management. The idea for this system comes from a real life observation at Dhaka Metro. For safety reasons, only 10 passengers are allowed on the platform at a given time. To make this possible, the system integrates multiple digital logic components that work together. First, RFID sensors are used to detect every passenger's entry through their ticket card. These signals are then passed through an ADAC which converts the data into digital form. A synchronous counter keeps track of how many people are currently inside the platform. The rule is simple: if the counter reaches 10, no more passengers are allowed until someone exit. For managing gate operations, I designed a finite state machine with 4 states: ideal, check, open, close. The finite state machine checks the counter value, decides whether the gates should open, and finally close it once the maximum of 20 tickets for the day have been issued. Uh, an alarm unit is also integrated. If more than 3 passengers cross the yellow line simultaneously, the alarm triggers immediately. I simplified the Boolean expression for this condition and implemented it with NAND gates using NAND gates. The alarm itself is driven by a 555 timer circuit which generates the required frequency and duty cycle. Another important part is DAC, which converts the passenger count back into analog voltage, sends it to the control room. For example, when there are 5 passengers, the DAC output represents 1.67 voltage, and for 10 passengers it gives 3.33 voltage. Assuming a 4-bit DAC with a 5 volt reference, while the system is effective, it also has some limitations. For instance, RFID sensors may not always be detect every passenger correctly because of magnetic field, and in a real life metro, crowd movement is often unpredictable. Also, the system relies heavily on a fixed maximum ticket limit which may not match real world demand. In conclusion, this project demonstrates how digital logic through counters, FSMs, DACs, ADACs, and 555 timers can be combined to solve a complex engineering problem in a real-world scenario. It highlights both the strength and the practical limitations of such a system. Thank you for your listening. Assalamu alaikum.